Good morning, good afternoon, good evening, everyone. Welcome to the Salmonella from Feed to Food webinar. I'm Morvarid Rezvani, Global Program Manager for Salmonella Control in Selco. And today I'm the host of this webinar, where we have two speakers. Here with me in a studio in Netherlands, we have Pieter. And Pieter is an expert in feed safety, raw material preservation, and also salmonella control in feed. He is technical commercial manager for raw material quality program in Selco, and he will describe how salmonella can occur in raw materials used in animal production. And online we have Marcus. We have Marcus Rostagno from USA. Hello, Marcus. And he's a veterinarian with a PhD in preventive veterinary medicine. And he is technical and innovation director for Selco USA. His expertise is in salmonella ecology and also gut health in poultry and swine. And he will describe how salmonella risk can be managed in animal production chain. Before starting with Pieter, I would like to inform you the webinar is recorded and will be shared later on within 1 week to all registrants. And I would like to ask you to put your questions in the question bar, in the question box next to the live stream screen. And with that, we can keep the webinar interactive. So we will have some moments in the webinar to answer your questions. And for the rest of the questions, our speakers will back to you via email after the webinar. Have fun, everyone, and Pieter, floor is yours.
Thank you so much, Morvarid. Welcome, everyone. Today I will be discussing a crucial aspect of feed safety, and that is controlling salmonella in our raw materials, also our feed ingredients. As many of you may know, salmonella poses a significant risk not only to animal health and performance, but also to human health as well. So ensuring the safety of our feed supply chain is vital in maintaining the integrity and quality of our products. So today I will be discussing or walking you through in this presentation just on some mitigating strategies that we can use when it comes to salmonella control in our raw materials or feed ingredients. Our goal is to provide you with practical insights, but also actionable steps that you can take to enhance salmonella control measures. So first things first, I think it's also good for us to understand what impact salmonella has on our society. So salmonella is a genus bacteria that causes foodborne illness. This is primarily transmitted through contaminated food or water, like raw meat, eggs, poultry, and unpasteurized dairy. This basically causes salmonellosis. So we see symptoms like diarrhea, fever, and in some severe cases also deaths, especially in vulnerable groups like the elderly, also infants, and then immunocompromised groups as well. The global salmonella infections is really a massive health issue. Over 600 million cases of foodborne illnesses are reported yearly, with approximately 450,000 deaths. So it's really quite a massive public health issue. What we can do from our side, preventative measures, is to make sure that we handle our food properly. We thoroughly cook our meats and our food. We avoid cross-contamination, and then also regular hand washing as well. Agencies like CDC, the WHO, they really have a lot of guidelines in place to help us control Salmonella in an effective way. So this is just the impact that Salmonella has on our society globally. And I also want to drill down a little bit more, just give you a brief overview of Salmonella, just in their thriving environment. What do they like? So Salmonella is part of the Enterobacteria family, so it's a gram-negative pathogen. It's almost impossible to completely eliminate Salmonella, so that's why we always talk about we are controlling Salmonella. It can really survive in quite cooler temperatures environments, but also quite hotter environments as well. Quite a broad range of pH as well, and it loves really free water available. So when the water activity is quite high, that's also when they thrive, and they can stay dormant for a very long time. As soon as we present that perfect conditions, temperature, humidity, moisture, then they can proliferate exponentially. Always try to keep them in that lag phase before they grow, because when they start growing, it's too late, and then it's really difficult to then start controlling Salmonella. So by knowing a little bit more, and this is just a broad overview of Salmonella, we can now look on how contamination can actually occur. So several sources of contamination. When we talk about the raw materials or feed ingredients like grains, your higher oilseed protein meals, also your animal byproduct meals, they can get contaminated through water, through also infected animals, so basically in storage or in the mill. During processing, and inadequate, let's say, processing methods when heat is maybe not sufficient to eliminate Salmonella can actually survive and contaminate the process or production further down. Cross-contamination in mills or in mixing equipment when there's not proper cleaning done, especially in these processes and the production which runs 24/7. It's very difficult or sometimes impossible to clean regularly because of production that runs 24/7. Environmental factors, I mentioned before, so temperature, humidity, also moisture, providing that perfect conditions for them to grow. So that's also a big part. Infected animals, especially rats, especially birds, they're big carriers of Salmonella, and they can also infect or cross-contaminate your clean, nice raw materials, not only in the mills or in the storage, but when we transport as well. When it's an open transport, that's also a vulnerable place for contamination. And then also on our supply chain, it's the supply chain, the feed supply chain is very complex. So there's a lot of different stages where actually contamination can occur, especially when biosecurity measures are failing. So these are more or less where we see contamination can occur. Also, some factors that also play a role in contamination is poor storage conditions. Also, specifically when you store your raw materials or feed ingredients for a longer period of time. Also, depending on which the raw material, again, oilseed protein meals or animal byproduct meals. If you store that for a long time, also creating that perfect environment to grow, then they're very susceptible for bacteria growth and Salmonella challenges. Also, when you have not the first in, first out method, when there's some bit older raw materials in a flat storage, let's say bunker, that's not used, that's also quite a big risk. Cross-contamination, inadequate hygiene practices, that works really hand in hand, especially if you look on your raw material intake. If there's contaminated batches and you only have one raw material intake, where everything goes through, massive recontamination and cross-contamination can occur. Also when it's improper cleaning, especially in conveyors, which is really in a closed system, it's not open regularly. There's some biofilm that can occur or accumulate there. So that's also very important. Cleaning is number one when it comes to controlling these bacteria. So these are the factors also contributing to contamination. And then the risk, or let's say the consequence of these contamination can be quite detrimental, especially animal health impact. So animals will also be infected with salmonellosis, very detrimental to their health, especially in younger animals. Huge economic losses as well, because now productivity decreases, more costs on veterinary practices, but also on the mortalities that really impacts profitability in the farming industry. Human health, so we also contract salmonella from infected food products, so that's also a big risk. And also the next one, a really big crisis that we're currently facing is antibiotic resistance. So really worldwide crisis now where the overly antibiotic use equals actually antibiotic resistant strains coming in. So now we also need to make sure that future handling of that or administering some antibiotics is different. So that also poses a very big challenge. And then also this puts a lot of strain on the regulatory bodies that they need to put in more rigorous controls and measures for salmonella. So really quite a lot of consequences and risks when we look at contamination of bacteria or salmonella. And now that we know on the contamination side and the risks that we face, we can actually start looking at what can we do as a first step to be able to control this sufficiently. And that's by measuring. So if we don't measure it, we don't know what we're currently facing, then it's very difficult to manage that. So basically, mapping that microbial blueprint, whether it be in your feed production, your processing, or even your storage side, making sure that we identify the different places or stages that's prone to contamination. Regular assessment of our cleaning practices. That also ensures that we have a higher standard in our environmental hygiene. Continuous monitoring also helps us to detect if there's sudden changes, and also early detection of contamination. So we really need to continuously monitor. And with this understanding, we can also minimize the risk of actually salmonella contamination. So we also, to adhere to certain, let's say, regulatory standards, we support this with documenting our microbial control measures, also our optimizing processing conditions, and then also training our staff regularly on good manufacturing practices. And also with regular assessment, we can also make sure that we really make a difference and continuously improve on the way we measure. So really important to measure, and then we can really try to understand and then manage this a lot better. And how do we manage this? And this is just one part, let's say, of the mitigating strategies that we can follow. But it's really putting in a structured sampling plan in place. So there's some 12 points here, and I also want to briefly just give you an insight on this. And this is really, firstly, to define our objectives. Is this to see where the contamination can occur? Is it to really monitor our hygiene practices? Or is it really to ensure product safety? So we really need to make sure that we know where we want to end up at, really taking samples throughout, raw materials, through the process, and also the final product. So really looking at all those stages of the critical control points. We need to make sure that we detail, intervals when we're going to take samples. There'll be daily, weekly, monthly, but also then event-driven sampling as well. Because when we see there's a Salmonella detection, we also need to make sure that we take samples and when there's higher risk times of the year as well. Also detailing the method of sampling, also the number of samples we have to take, and also how big the samples in representation should be. And also having that standard operating procedures in place, but also then training our personnel to make sure that they know how to effectively sample the different stages in the process. Also important from a traceability perspective as well, to label your samples correctly, date, time, and where you've taken it, location as well. So that also helps with the retention samples, and that there's traceabilities back to make sure that we have all of those in place. Also adequate storage, and also make sure that when we transport it, it's also done in the most effective way. When we look at lab analysis, we need to make sure that we use accredited labs so that we have reliable results and as quickly as possible. We need to use the results that we get to actually make sure that maybe there's some trend of contamination and really to implement, let's say, the corrective actions. So we really need to use the results to better ourselves at the end of the day, and continuously monitor. We need to continuously find ways to make it also more effective. Maybe change the critical control points around, or maybe the frequency around. So we always need to make sure that we continuously improve on these types of plans, and also report and communicate internally. I think that's also very important to make sure that the right people know what is happening in the different stages, from production to quality to storage, that everyone's on the same page. So just in a nutshell, this is what a structured sampling plan would look like. It might be different for different types of, whether it be production, processing, storage, but this is a really good base to start from. And I really want to highlight two points here. The first one is critical control points. I think that's also something that we get a lot. Where is the correct critical control points where we need to take our samples? So this is basically the stages in the process, whether it be feed production again, whether it be processing or also in the storage, where we actually can control to either eliminate or reduce contamination, whether that be on Salmonella contamination, might be chemical contamination, also foreign materials as well. So that's really the stages in the process where we can apply control. Also, when you look at the processing side on the heat, to make sure that we have sufficient heat to eliminate Salmonella so it doesn't survive and contaminate the rest of our lines further down towards the final products. Making sure we have adequate storage. Also, making sure from a transport perspective as well that we eliminate, let's say, recontamination. So all those critical control points, and again, it might be a little bit different in different factories, but this is also a good way of looking at certain areas that we might find that there might be a big risk for contamination. The second one is then the sampling itself. I think I put there firstly, make sure you are fully prepared. It's not only on the sampling, let's say the gloves, the swabs, the final feed containers or the Ziploc bags, but also from a safety perspective. We are entering, obviously, processing or production facilities that's quite dangerous. A lot of movements, forklifts. So really take care on the safety side as well, something that we put obviously also as a number one. Wear the correct PPE. I think that's very important. Clearly defined, again, then the CCPs, and that you can also be led by the QA of that particular facility. You also see where they currently take samples and see where we can add maybe some different CCPs, maybe a conveyor belt that has not been open in a few months or years that can maybe accumulate some biofilm as well. So stuff like that we can add. Again, like I mentioned before, clearly mark where we've taken the sample so that we get a good representation of the whole process and get it as soon as possible to the lab. We want to make sure that we get the most accurate results, and that is if we get the samples to the lab as soon as possible. So this just from the sampling perspective. I've mentioned a couple of times the higher oilseed grains and the oilseed meals and the byproduct meals. So also, why are they so susceptible for bacteria growth or salmonella growth? And it's basically two things. So really the composition of the products, a very nutrient-rich environment. Again, very nice for the bacteria to thrive in. But also then the pH levels. So it's not that acidic, also not that alkaline. So it's really also providing that perfect conditions. And again, what all these processes have in common, let's say, is the addition of moisture during the processing of these byproducts. And that also, again, coupled with humidity, coupled with temperature, provides the perfect conditions for salmonella to grow. So that is why these types of raw materials are very susceptible for bacteria growth, salmonella growth. So with that being said, looking at our mitigating strategies, and it's really looking at a comprehensive plan. I've mentioned previously one of those, which is the sampling plan, that's really looking at a holistic approach from, let's say, supplier management, where we audit our suppliers on a regular basis, where we get COAs to make sure that the quality that they promise is the quality that we get. We do routine salmonella checks as well to make sure that it actually not contaminated goods that's coming in. Also on the processing controls when it's in our plants, to make sure again that there's sufficient heat treatment, that we make sure we sterilize those products as it goes through the whole process. Also making sure that there's a rigorous cleaning plans in place to make sure that we, from the environmental perspective or from our from the production procedure, that we keep that also so clean. Continuous monitoring and surveillance, that's a very important. We need to measure that we do through the structured sampling plan. And when we get those results, we are able to actually identify where the stages are, which is prone to contamination, and what corrective actions we can actually take in order to mitigate those risks in the best possible way. So it's really looking at a holistic approach. And that's also how we approach it from our side. So the raw material quality program, as part of the Salmonella program, is really looking at the holistic approach. Really looking, and it's based on these three pillars. So really from an analytical side, again, feed safety audit, mapping that microbial blueprint so that we can recommend the best way forward. Also from a product portfolio side, organic acid-based products that's specifically blended to specifically target salmonella. And then also from a dosing perspective, so really coming full circle on the service side to make sure we also dose accurately, but also safely. We need to make sure that safety is also one thing that we put very high on the list. So really taking that holistic approach when it comes to helping you mitigate the strategies or mitigate the salmonella and using these strategies. So with this, I'd like to thank you for your attention. I hope I've given you a good understanding of, in a broad way, of salmonella and the risks that brings, and how we can look at ways to mitigate that, and really looking at the whole holistic approach and not maybe just one aspect, but it's really a continuous effort to make sure that we do our part and be responsible in the feed and food safety sector.
Thank you, Pieter.
Thank you.
Great presentation, very insightful, and we received some questions for you.
Okay, yeah.
Yeah, the first question is about raw materials.
Okay.
And what are the most effective methods to prevent salmonella contamination in raw materials?
Okay. Again, I think it's more than just one thing. It's really to see from the raw material intake side to make sure there's some sort of control. There's some sort of, from the supplier side, that we make sure that we take care in that sense. Also in our procedures that we have, the hygiene practices that we have in the plants, that we do our due diligence in that side as well. Again, using the heating as an example, also those critical control points that we make, we have sufficient processes in place. But then also looking at the way we approach, not just on the organic acid side, not just for decontamination, but also looking for that recontamination to safeguard against that. So it's really a holistic approach than just one simple thing that we can do.
Yeah, thank you. The second question we receive is about the feed sampling.
Okay.
And how we can ensure that it's reliable, it's in a reliable way.
Yeah.
And
So that's also a question that briefly touched on that, but I think it also goes to the fact of we need a good representative sample. So we need to take actually more samples. We need to take a good representative sample that we can see exactly what the current situation is and what risks we face, basically. And then again, the labeling is so important that we know where we've taken this, and then also as soon as possible to the lab. I think to get those accurate results, making sure that we use those results in order to put in corrective actions. So I think that would be the best way to approach it.
I think for the lab part, we have also some support here.
Yeah. So we can also provide. We have a lot of labs also across the world that can actually assist with that. So that's also from our side, also one of the pillars that we can provide.
Perfect. And last question for you is, if salmonella is detected in a batch of feed ingredients, what steps should be taken?
Okay. Yeah, this is also quite difficult sometimes because it's depending on which country we're in and the regulatory let's say, rules in that country. But first things first is quarantine. So I think just to make sure that we quarantine that batch, and so that recontamination or cross-contamination cannot occur. Then also using either heat treatment or basically organic acid treatment as well, to make sure that we eliminate the risk. And then very important to also analyze again after treatment to make sure, and again sufficient sampling to make sure that because salmonella is quite, let's say, sporadic, so it's quite mixed. It's not homogeneously through the mixture. So we need to make sure that we take enough representative samples and that it's actually coming back negative, basically to be released. So those are the three factors that I would look at.
Thank you so much. Thank you
you.
so much. After looking into the feed safety part, let's move to Marcus for the next presentation to cover more about the animal production chain. Marcus, floor is yours.
Thank you, Morvarid. To the audience, wherever you are, welcome to our webinar, and thank you very much for taking the time to join us and listen to our presentation. We really appreciate it. Um, so, without delaying, let's get right into it. But my goal here today is basically to deliver three things to you. One is I want to explain to you and make sure that you understand, since we are talking about controlling salmonella, you need to first understand why this is such a challenging topic for the poultry industry, why we deal with salmonella for decades and we're still talking about it, right? And so this is something that it needs to be understood in order to know how to control it and how to go about it. That leads me to the second objective, which is exactly to give you a sense based on those challenges how a salmonella control program should look like. What are the components, at least? Of course, we can get in this very limited amount of time to walk through a very detailed program, but at least gives you some of the different components and a general idea of how it should look like, at least a framework, let's say. And then finally, the question as we look at the control and we see the challenges, how complicated, how complex, let's say not really complicated, but complex, and how labor intensive, how tough is the execution and the requirements for this. First question we get back is it worth it? Well, I'm going to try to show you that an answer to that question, if I may. So let's get started with the first question right off the bat. Why is it so difficult to control salmonella in poultry production? Right. First is considering that along the chain, which is very long. Here, my focus is primarily the farm, but we just talked about the raw materials, the feed, then you have breeders, then you have hatchery, then you have processing. There are a lot of opportunities along this chain. This whole system, it was not developed with the mindset or the understanding of microbiology. It was developed to be efficient, to move the whole production through this process, to make it, to produce volumes, to make it more practical. So a lot of these challenges we face today with pathogens, particularly, are due to how we manage all these process, and we are trying to adjust it as we go. Now, besides that situation, we have what I call the human factor, which is it's heavily involved. Individual people, humans are heavily involved in this whole chain. A lot of things needs to be done, and whenever you have humans, what happens is you will have errors, you will have mistakes, you will have things happening that open doors for these risks, for these pathogens, for and some other things that could happen. So in the other side of this equation, let's say we see the pathogen itself, right? We tend to think on salmonella and we use the term salmonella, and everybody keeps in their mind that, well, this is a pathogen, but it's not true. This is a very large group of complex pathogens. All right, salmonella, last time I checked, there's been over 1,600 different serovirus or serotypes, depending on how you call it, have been identified throughout the world. So we are not really talking about that one. We're talking about over 1,600 different types of salmonella bacterial pathogens. Right? Let's narrow it down a little bit. Let's think about poultry production. Well, yeah, not all these 1,600 or 1,600 affect everybody, but let's narrow it down. Just for poultry, you're going to be talking easily over 50, maybe even close to 100 different serotypes or serovars that can be found in poultry. And all of them, what happens is, and you saw some examples that Peter showed, they're very resilient. They can survive for long periods of time. They can easily spread. They adapt to different conditions, humidity, temperature, all these kind of things. So that complicates a lot. If that wasn't enough, we also have another component here, which is the tools that we use to measure and to track and to monitor salmonella are very limited. We have limitations in precision. Usually the precision is not very good, and there is a lot of noise, what I call, in the system. One of that will be the sampling, right? There is no such thing as a sampling. The ideal sampling will be 100%, but we can't collect 100% of samples. So we collect a subsample or a small portion of the whatever we're trying to sample. It implies an error. There's always a marginal error in that sampling. Put on top of that, that contaminations with salmonella, whatever you're talking about, facilities, equipment, ingredients, feed, whatever, even the birds you will see in a second, are not homogeneously distributed. There happens in clusters, so it's very easy to miss them during these samplings. On top of that, these clusters, a lot of times, they are in very low levels, which leads to the last point, which is our detection and isolation methods are not perfect. They have certain limitations, being diagnostic or analytical sensitivity. They have certain levels they need to be able to detect it. So this complicates a lot something that it's already very complicated, very complex, right? So to try and explain a little bit what I mentioned, the dynamics of salmonella in broiler flocks is not static. It's not like a whole flock is infected at once and they all have the same situation. It's not. The initial exposure, it's associated with the susceptibility of the bird. Depending on when that exposure happens, that colonization may or may not happen. And if it happens, that can be disseminated to a different number of birds, but it also can be cleared, right? The bird can, its immune system or a microbiota can eliminate that salmonella from their GI tract and they become clean again, or they may persist and stay infected, colonized, and disseminating that bacteria for longer periods of times. Well, on top of that, we have not all birds are infected at the same time or with the same levels. That doesn't happen. So with that, you have variations. Some birds will infect at some point, some others at different time points, and that's going to go changing throughout the production or the growth process of these birds. Then the levels also will determine how much they're disseminating, if they're clearing, or if they're becoming persistently infected. And even if they clear that infection, they can be reinfected later on in that cycle. Well, again, if that wasn't enough, we also have all these different serovirus happening at the same time. So it's very common when collecting samples in flocks to find 2, 3, 4 different serovirus happening or occurring at the same time, or in different times during that cycle, production cycle. So these combinations of factors give us what we will call the real prevalence, right? Which by itself will vary over time just because of what we discussed here. On top of that, we add the methodological limitations that we discussed a minute ago. Then what happens is we actually don't work with the real prevalence. Most of the time, we work with what we call perceived prevalence, which it may not be real. It may be higher or maybe lower than the real prevalence. So what I used to call here is when you're trying to monitor salmonella, what you see is not always what you get. So you have to be very careful. So then the question is, okay, I'm collecting samples, I'm monitoring salmonella. What do I do? How do I look at these numbers? How do I look at these incidents? What I tell people is you need to be very careful. You need to look at the data. Do not look at snapshots or short periods of time. Depending on your graph on the left, if you see different time points, different time windows, you're going to get a different perspective of what you're seeing. You may think it's going up abruptly. You may think it's going down. You may think it's stable, depending on the window that you are looking at. So it's very important to look over time, long periods of time, long term, to really understand what's happening with salmonella in your system. There are different tools to analyze to do that. It's not our topic here today. This is a topic for in a presentation in itself, but the one that I've used the most, that I'm more comfortable and that I think it reflects and works well, is the statistical process control, where you can over time determine what is the variation acceptable, let's say, or inherent to your production system, and when you are able to pick up single or a specific influence or factors that are leading to, oh, there was a spike or a drop, but is this normal, or is this one factor that happened that caused that variation? Or if there was a systemic change or something more consistent that will cause what we call a process change or a system change or effect, which is going to tell you, okay, we are in the right track, we are consistently reducing, or no, we are stuck in the same pattern, or we are moving up on this pattern. So Salmonella, bottom line is, requires a long-term longitudinal perspective. Do not focus so much on individual time points or short periods of window. So with that said, with everything that we just discussed, you saw the complexity, you saw the challenges, the limitations we have. So with that in mind, yes, you monitor, you track, as was said before, you need to measure, otherwise you don't know where you were going, but it's hard to react at real time. You need to look long term, but you have to do something in the midterm. You can't wait to see where is it going to go. So with that, instead of really focusing on controlling Salmonella, you have to control the risks. What causes Salmonella to happen, to occur, to increase? What is happening there? What are the risks? And then Salmonella becomes the outcome of those risks. So basically what we have to do in any part of the chain is risk management. When you identify the risk, you analyze the risk, you act on it, you monitor if your action is happening or not, and then you determine if you're controlling or not effectively that risk, and if the outcome is under your control. And then repeat that cycle over and over again, because we know the risk factors, as we're going to cite some examples, change over time. And what we do, what I tell, the analogy that I usually use is the race when we race and with obstacles, is we keep putting obstacles, these risk factors we keep controlling. Basically, we keep putting obstacles in front of Salmonella, and each stage of the chain, the breeders, hatchery, feed mill, farm, and so on. So we minimize in every step, and we make the interventions in the next step more and more effective. Right, so that's why I keep saying you need to have the whole chain involved. If you focus on only one point, it's going to be very, very difficult to be successful. Now, the problem is, what is our main challenge? The main challenge is there is no magic bullet. And the problem with that is humans love the magic bullet, the easy way out. And so they don't want to change, and they resist change. That's why you need to keep reevaluating. And a lot of the risk factors are linked to behaviors. And this is something problematic. That's why it's important to have a plan where you don't think, oh, this is too difficult, give me a magic bullet, give me the product X, but they told me it works, let's use it and let's see what happens. Well, the upper corner there, it's my reaction when I hear that. What can I use to solve my Salmonella my problem? I say, wait a minute, it's not like that. You need a structured plan specific for your system, and it needs to be systemic, consistent, and persistent. Remember the longitudinal approach. You're dealing with three different things: the animals, the host, Salmonella, the pathogen, and environment, and on top of that, the human factor that influences everything around that, right? Again, I keep talking about a chain. We just heard about the ingredients, the feed. That's one part of the chain. Then you have the breeders that produce the eggs, the chicks that go hatch. Then you have the hatchery. Then you have the farm. Here we're just talking about the farm, right? But just want to make sure we're regrounded on this. And when we look just at the farm, there are a variety of risks or areas that we have to look at, we have to monitor. One goes from cleaning and disinfection of facilities, equipment, everything involved, hygiene on a day-to-day basis, right? Other animals in the premises, wild birds present or having access to the feed, to the people that come in and out of the barn or inside the barn, depending on what type of barn you have. Rodents also carry pests. Insects are also good carriers of Salmonella. Water quality is a key issue, frequently forgotten or ignored, right? Not only the water itself as a source, but people focus a lot on the water and forget about biofilms in the pipes and the whole system that can be created over time and established, and is very difficult to remove, and it can from time to time be released and infect flocks. Feed, we just discussed. You saw that there are some complexities there as well. Chicks, they can come infected, being originally from the breeders or getting contaminated, infected in the hatchery or in the transport. Personnel, again, the human factor, hygiene, washing hands, clothes, boots, where you go, all these kind of things are very, very important. So you can see that if you have a little bit of experience in poultry production, all these points are touched or approached in a biosecurity type of program, right? And so this list can go on and on and on. This is just an example, right? We could come up with many, many different slides and pages with each one of these topics. There are a lot of details, but just to give you a sense of how broad the biosecurity, and particularly if you target Salmonella, what you need to pay attention to, all kinds of details that risk introducing or favor dissemination or persistence of that pathogen in your system. So that's going to be the basis of the program, the controlled risk factors, which will be our strong, detailed biosecurity program. So, but people ask me all the time, what are the most frequent and consistently observed sources of introduction of Salmonella in broiler flocks? And the two most common are the chicks themselves and the feed. Chicks are commonly infected. The problem is it's very, very difficult to pick it up. Why? Because it's very, very low incidence, right? Breeders have usually a strong monitoring control program. So whenever there is a positive, it's very, very random, very occasional. Hatchery also has, so you will have some chicks occasionally become infected, but it's a very, very, very low frequency. It's hard to pick it up based on sampling. Remember, sampling has error. You can't sample every single chick, but it happens. They can bring contamination into your system, and it's frequent, right? And the second one is feed, which we already heard, and we know it's a continuous exposure system. Feed keeps coming in continuously. These birds consume this feed all day, every single day. So the probability, it's very, very high that you will have feed introducing Salmonella into your system. So these two are very, very critical to follow. And one thing that's very important here that I like to highlight, there is a very vulnerable moment here that combines these two factors that we just talked about, is the placement of these chicks. These chicks come with a very clean GI tract. They have very, very low levels of microbiota and microorganisms, so it's very susceptible, very open to any microorganisms that can come in and colonize. And that's where they're exposed, or to the environment, to the litter, for instance, or the contaminated equipment, as soon as they get to the farm. And as soon as they start eating, that might be the first time they're exposed to Salmonella. So it doesn't take much to infect those birds, right? So this is a very, very high vulnerability time. The first few days of placement, that is very high risk. Now, we couldn't talk about Salmonella control without at least touching on feed additives, something that we all hear, and we have a lot of this in the market. We have a huge range of options available. All the biotics, pre, pro, syn, postbiotics, organic acids, and many, 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 many different more that are available in the market. What is a challenge here? Most of them, if not all, they do show and have shown under research conditions reductions effects. Remember the point here that I highlighted, that reduction. It's very difficult to clean a bird once it's colonized, is infected, right? So, but under research conditions, under control conditions, which sometimes are not very realistic, you can demonstrate reduction. Right? However, when you take that to the field and you start using these products in the field, that's when you start facing variation based on everything that we just talked until now. Maybe the product is working, but there are other issues, risk factors, or issues that we are not considering on doing it right, plus how we measure and so on. A lot of these measures are tie point. This flock against that flock, one time point, one sample, we compare. Well, you may be getting noise, you don't know exactly. So, but they're usually the concept of using these products is essentially to reduce the chance of colonization or increase colonization resistance, lower as a consequence environmental contamination, excretion of these bacteria, and of course, consequently reduce transmission. Water additives play a very strategic role in key points of the production. They can be very, very helpful, easy to get in and out, but always remember the quality of that water. And vaccines more frequently, more recently have gaining traction, but they're much more targeted type approach. They can also help with these three potential benefits, and they can be a nice combination in control programs. So final stretch here, running out of time. First question I get when we go through all this is it possible? I say, yes, it is possible. Many flocks and companies have done it. Then what I mentioned at the beginning, is it worth it? Because all these cost money and a lot of investment in resources and focus and people. So as long as you see these as a whole program, which remember, controlling risks, risk assessments, monitoring, you're using, applying different strategies and intervention tools that we just discussed according to your situation and along the entire production and processing chain, yes, you do. Remember, everything is based on the biosecurity program, right? When you talk biosecurity, it's an insurance policy. That's what I call, because it's not just for salmonella. That's the benefit of it. By doing all this, you're also protecting your flock but beyond just salmonella, to other pathogens. And that is very, very important today with several other diseases. Second, we have to understand that we're not in the business of producing animals or raising animals. You're in the business of producing food, right? And depending how your company, your production, where you supply, how it is structured, this is very important. Recalls are easily traceable nowadays. You have traceability everywhere. Liability, your brand equity, what is the impact of that? Or even access to some markets are limited, or some places you want to put your product, you can because you have certain levels of salmonella. So that's very important to do that. And finally, just to show you something that's a question that debatable. Does the salmonella infecting birds, since it doesn't cause clinical disease in the birds, does it affect the performance of these birds? Many control infection studies have shown, here we have just two examples, I'm not going to go through the details, again, topic for another presentation, do show effects in feed intake, body weight, and feed conversion. And most of these studies also show effect in the gut morphology, reduction of villi height and increase in crypt depth, which is not good, right? So in general, you do have activation of the immune system, particularly of the innate immune response, and that is costly to the animal. And we can just put some points there, but we can discuss this some other time. But yes, there is evidence. Difficult to pick it up in the field? Yes, again, another discussion, but it does have an impact on the birds. If you're not seeing it, doesn't mean it's not happening. Very likely it's there. So with that, I'm running over my time. I appreciate your attention. Open to questions if I can help.
Thank you so much, Marcus. Great presentation. And we have some questions for you. You mentioned there are many different serotype for salmonella, and the question raised, should a salmonella control program be for salmonella in general or serotype specific?
Good question. This is a debate. It comes a lot from the public health point of view because they tend to categorize in terms of virulence or pathogenicity of different serotypes, what are the most important. And so governmental agencies, they tend to lean towards that risk, right? Because exactly as I mentioned, the group is so diverse that they realize, well, how do we do this? However, from the practical point of view, at the farm level, it's very difficult to separate them. And as I mentioned at some point during the presentation, it is very common to have multiple serovars or serotypes occurring in the same flock even. And so it's very difficult to target one specific. Vaccines may help a little bit on that, but if you look at all the other points that I raised during the presentation, they're general. They are really not serotype specific as we would like to be, right? But unfortunately, depending on where you are in your control program, some companies have been doing this for longer. They're much more advanced in that journey, I call that adventure, better say. So they can start targeting, or they have already narrowed down to the most common serotypes they have. Others are just starting. And so if you're just starting, I tell people, well, first let's learn how to walk, and then we'll start thinking about running. But we're not there. It takes time.
Thank you so much. And there's another question. You mentioned different stage of the production chain. Regarding to these stages, does the prevalence of Salmonella during processing reflect or correlate on farm prevalence?
Yeah, that is also a very common and good question, particularly because everything started there, right? Everybody started because of the salmonella contamination of on the processing and final product. That's when everything started backing up to production and so on in the chain. But also because of the convenience, it would be much easier. We could collect way more samples faster and monitor flux more closely if we collect samples during processing. Well, there is a problem there, and I work on that interim for a while. There is what I call a gray area between the farm and the processing, which I call when between picking up these birds at the farm and hanging them for processing at the plant. A lot of things happen there that a lot of people don't realize. A lot of these points, transport, handling, crowding are very stressful for these birds. And it's been shown multiple times that stressors spike salmonella in the GI tract. So levels of salmonella are increased in the GI tract of birds if they are infected or colonized with salmonella and subjected to stress. Plus, it predisposes birds to be infected if they were not already. And the close proximity in the transportation, the resting, pre-processing favors that transmissibility. So unfortunately, it's very difficult to establish that correlation because of all these confounders that happen in between. I wish we could do that, but practically is not that easy.
Thank you so much. We have some more questions, but because of the time, we cannot answer them now. But no worry, we will send the answer via email to you. And by that, we reach to the end of our webinar. And let's strive for a future where our animals are healthier, our food is safer, and our world is better. Thank you so much, Peter. Thank you so much, Marcus. And it was great and very insightful presentations. And thank you everyone for joining us. We appreciate your active participation and your attention, and we are looking forward to seeing you in our next webinar. Till then, stay safe and keep making difference. Thank you and goodbye.
Goodbye.
Thank you. Bye.